Well, good morning, everyone. I see that you found our new classroom location. I hope you had a good weekend. Could you draw those blinds just down most of the way? It's always too short, right? Yeah. Never long enough. The same thing is true about lecture, though. Professors always feel like the class is too short. It's never long enough. There's so much more we could say, but I know students have a different point of view about sometimes the lectures, and that's okay. So our first announcement is something you already know because you're here. So I'm preaching to the choir, as they say. Our new classroom location is here. Now, occasionally through the semester, we're going to go into a computer classroom so that everyone can be using Excel. There's a lot I'm going to teach you on Excel that makes it so much easier to do financial calculations. I'm sorry, you can't come in once the lecture begins. So occasionally what I'll do is I'll put the announcement on iLearn, and I'll try and remind you the lecture before and as well. But generally what that'll be is just downstairs in the same building in one of the computer classrooms. So we'll probably start doing those next week, as early as next week, I think. The next announcement is that your homework assignment number 2 is due at the beginning of class on Tuesday. And if you've already looked at that, you know it's a relatively quick and painless assignment, so I don't think it'll be any trouble getting that done in time for Tuesday. Also, though, remember that that's due at the beginning of class, so even if you're 1 minute late, that means you can't submit the assignment. So please have it stapled and on the table there before we begin class on Tuesday. Any questions related to these announcements? All right. Well, we're going to continue talking about cash flows today. We already took a quick initial look at cash flows in a previous lecture, but this lines up to section 1.6 in the textbook. And I'll remind you that you paid a lot of money for your textbook, or someone did at least, and so you should make the most of that money by reviewing the sections of the textbook that relate to what we're talking about in class. It's a really good way to get a different point of view besides just how I present the material. There's additional examples, there's additional figures and tables, and so you should use every opportunity you get to learn the material. So I'll try and point out with each lecture what we're talking about and how it ties into a certain part of the book. So really, it's a great idea, even if you just spend 10 or 15 minutes after each class to review what's in the book. That'll help you out a lot. Okay, so let's begin with some terminology. And this is another situation where perspective matters a lot, whether you are the bank or whether you are the person borrowing money, or in the case of a small business, whether you're the business owner or someone who's making payments to a business. At the beginning of any kind of a problem, you have to establish whose point of view you're working the problem from. And so from your point of view, a cash inflow is going to be any kind of money that comes to your business. It can be revenues as a result of the operations that are being undertaken, whatever it is the business is selling or doing, if it's a service or if it's a good that the business is producing. Revenue is getting paid for that. Receipts means the same thing. If you're talking about personal finance, it can be your income, meaning salary. The next one's a little bit less obvious, and that is savings generated by projects and activities that flow in. So every company has expenses and costs, whether it's the labor costs or the expenses of fuel, utilities, rent. There are so many different kinds of ways that you're having to pay money when you operate a business, or in personal finance as well. When you have an expense in the past, something that you're used to paying, anytime you realize a savings, we're going to consider that as effectively a cash inflow. So if your landlord agrees to give you a discount on the rent, you'd consider that as an inflow to yourself. Or if you invest in a new piece of machinery, and then over the long term, that machinery is going to reduce the expense of labor, then you could consider that future savings as an inflow. So when we're doing calculations, we consider inflows as having a positive value. Outflows are varied as well. That can be payments to vendors, it can be payments to employees, costs, having to do with taxes or fees that a business has to pay to operate. And so it's any kind of money that's flowing out. Remember, in a previous lecture, I referred to the idea of a tank. And so if we use, fluid mechanics as sort of a one basis of comparison, there's money coming in and money coming out in the same way that water can come in and out of a tank. And so the net cash flow is going to be the difference between the in and the out, in the same way that you have a change in storage. And so the storage in the tank will be increasing if you have more flow in than flow out. And the same thing is true with net cash flow. If you take a look at a certain time period, whether it's every month that you're doing the books or every year that you're doing the books, and you total up all of the receipts and all of the expenses, then the difference between the two is the net cash flow. Yes? It means paying out. Yeah, it's just a complicated word for any kind of an outflow of cash, a disbursement. Now, there's something that's important that you're going to have to know is our default assumption. And you're going to look at a lot of problem statements today. The in-class exercise we're doing, the whole purpose of it is to get you more familiar and comfortable with interpreting the words of a problem statement. Because sometimes the hard part isn't the calculation. Sometimes the hard part is just trying to interpret what the author is really asking. And so that's why we're going to do some more examples related to that. But built into those examples is that the default assumption is the end of period assumption. So that means that when you have money coming in, let's say in a problem it says you receive $5,000 per year. Now, we've already taken a sneak peek at what a cash flow diagram looks like. I've already showed you that we put these tick marks in and we have time on the horizontal axis, and then we just number the periods sequentially. And so the end of period assumption means that if you're used to getting money every year, you get $1,000. So that's an inflow to you, and we do inflows here in the above the line. You would put when that money comes to you at the end of the period. And it can be sometimes confusing even just to interpret what these tick marks mean. And so 0 means at the beginning of the problem statement. 1 is referring to the end of the first year. So here is the first year. It's a segment. But then the end of this first year is just a single instant in time. And so these tick marks are referring to the end of the first year. Here is the end of the second year. The second year itself is this entire line. But the end of period assumption means that for simplicity, sometimes we consolidate all of the inflows and all of the outflows that happened during the entire period to just one event at the end of the period. And so if you're operating a business, maybe you're buying and selling things every single day. But then in a cash flow diagram, just to simplify it, instead of having so many tiny little lines through the entire year that would be impossible to see, we just add up all of the inflows and we would put it at one instant at the end of the time period. So does that make sense? End of period assumption. All right. Some cash flows we know the exact amount, and we can just use a single value to represent that known amount. And so if you had an income of $150,000 per month, then you could draw that as a line. But if it's a range estimate, there's a couple of ways we could represent an estimate. And one of the most common ways to represent an estimate is with a series of bars. So if you had a cost, this is an outflow, so I'm going to draw it below the line. If it's a cost is between 2.5 million and 3.2 million. Let's say that we have to pay that now, so I'm going to draw that at year 0. So if that's an expense of between 2.5 and 3.2, what I do is I'd have a line going down, and then here is 2.5 million, and the line continues, and here's 3.5 million. And so this is just a range bar. that's showing the cost is somewhere in this range between $2.5 and $3.5 million. And this is the first time I'm going to introduce an idea that's a really important concept that is going to come up a lot of times in the course, and that is uncertainty. Now, we're going to be making projections about what happens in the future, but we don't really know exactly what's going to happen in the future. They're just estimates. In the project, for example, I'm going to be asking you to estimate your starting salary when you graduate from the university. And that's not too hard to do. I mean, you can talk to people who've graduated recently and find out what they're earning. You can go online. There are some salary estimates that are published online. So the short term is sometimes easy to predict. But what's harder to predict is what's going to happen to your salary in 20 years. You know, after 20 years on the job, there could be a lot of inflation. Maybe you got some raises or promotion. Maybe you changed companies and you're doing a completely different task now. And so there's so much uncertainty where we may do a drawing with amount estimates. You know, maybe we're going to say, well, here's your salary over time. It's getting a little bit bigger every year, and that's great, but it's just an estimate. You know, we'll do our best to calculate based on these estimates, but we should always, in the back of our mind, acknowledge the fact that there's a lot of uncertainty built into financial calculations, especially when you're predicting the future. We don't know exactly what interest rate we'll make in the future. You remember when we were doing the in-class research on your phones or on the computers, there's a lot of different banks out there, and they have a huge range of what they pay or what they charge in interest rates. And that could change at any time. If the central bank makes a change in how much they're charging banks, you know, the governmental bank charges the corporate banks money for the privilege of borrowing money from the government. So they can change that, and they can change it at any time. So there's a lot of uncertainty. So here's how we're going to do the cash flow diagrams. The periods may be months, they may be years, but we're going to start with the horizontal line and then start putting these tick marks in it to represent the duration of each period. And as I've already mentioned, the duration of a period is the distance between the two tick marks, and so the time period itself is this blue bar here. But then the end of period assumption means that we usually represent the inflow or the outflow at the end of the period with a line up or down. Sometimes a problem will specifically tell you that it's at the beginning of the period. And so, you know, a problem statement can override our default assumption. But, you know, thinking back to last semester, I don't think there were actually any of the homework problems that did that. So, the cash flows should be approximately to scale. You know, we'll do lines, and the length of the line should, you know, roughly represent, the magnitude of the line should represent the amount in question, where you can see this line segment is maybe a little bit longer because it's $100 than the amount that's at the present, that's 80. One thing I'll mention to you is if you've printed out the notes already, in the notes it said negative 80. And I've taken the negative sign out of that because it was redundant. The sign, the direction of the line already tells you that it's an outflow because it's down. And so I wouldn't require you in a example or in a homework or exam, I wouldn't require you to put the negative sign next to that 80 because we already know it's an outflow, the line pointing down. What else to tell you about these? And as far as, you know, how exact these drawings have to be, you don't need to get out a ruler and measure, you know, this is 8 millimeters, so that should be 10 millimeters. That level of precision isn't required. These are just conceptual drawings, and the benefit of having them is once you have translated a word problem into a sketch like this, then the next step after that, starting to do the calculations, is so much easier when you're starting with a good cash flow diagram. So that's where really the benefit comes from. All right, let me hand out today's in-class exercise. There's a couple of steps to this. The first thing is I'm going to ask you to think about differentiating between inflows and outflows. You've already seen the definition for each of those. And so the university here, AUS, has a variety of inflows and outflows. And so in problem 1, you're going to take the university's point of view. You know, the accountant at the university, what money comes into the university versus go out. So you're going to categorize this list of expenses and revenues in terms of an inflow and an outflow. On part 2, I'd like you to translate the cash flow diagram that's given into a tabular expression of the same data. So it's just interpreting the drawing. And then there's also some questions on the back. Okay, so for this, it's good to collaborate with your classmates. That's why we've changed into a different classroom. You know, this room that has the tables is much better for collaboration than where we were before. So I don't expect it to be museum quiet in here as you're working on this. It's fine to be talking, and I'll break in as necessary when I've got something to share with you. Now, some of these you've maybe never heard of before. That's fine. Okay, the parking fee. From the perspective of the university isn't paying anyone for parking. It's receiving money from the students or from whoever's buying a parking pass. So that's an inflow. The salary, the university is paying the salaries out. So that's an outflow. Travel reimbursement, I've listed as an outflow. What that means is if one of the employees of the university goes on a trip, then, and it's official business, then the university will be paying the airfare, the hotel, reimbursing what the employee spent while they were away on that official trip. So that's an outflow. Tuition is an inflow. They're receiving money from the students, and so from the perspective, from the mindset of the university, that's money that's coming to them. The same thing is true of the application fees that people pay to be considered. Retail outlet sales, I got a lot of questions about that. That's sort of like, think about the Subway on campus or the bookstore. You know, it's all of the businesses on campus. The university is getting some portion of that as an inflow. So retail outlet sales is here in the inflow column. Savings from more efficient cooling. Remember, on the slides earlier it said if you have some expenses and then you save money on those expenses, it's effectively an inflow. So that's where I've got savings from the cooling system improvement. Software licensing, maybe Microsoft Excel or a statistics program. You know, all of the programs that are on the computer lab software, computers, they have to pay a fee for that. So that's an expense, software licensing. Patent commercialization. An employee of the university, if they had a new invention, and that invention they sell to a company to begin making a product from it, then the university would get some revenue. And so that's why it's listed as an inflow, is because if you're an employee of an organization and you come up with a patent, then some of the money will go to the university for that. Okay, I think the last three of these are all outflows. Visa sponsorship fee. You know, the university has to pay in order for me to be here. Like, I have an employment visa through the university, so they have to pay all the application fees for that. They have utilities to pay, and then loan interest. Now, I got a couple of good comments about the loan. There's two things with the loan, right? At the beginning of the loan, the money comes in, but then over time, you have to pay the loan back. And so specifically here, it was asking about the loan interest. And so that's an outflow from the perspective of the university. They're paying the money back. Any questions about this first one? Which one? Oh, I've taken that off? Yeah, I think I eliminated it because it was confusing. All right. Yeah, that's a previous semester. Let's look at the cash flow diagram here. Okay. Each of those lines is the same length. 1, 2, 3, 4, 5. Those are all the same length. And where it says A1, the A that's there, it means it's an annual series. That's what the A stands for. We'll talk about more detail annual series in the future, but you've now seen an annual series. An annual series is recurring, and it's the same amount. So it's implied by the line length, and then it's confirmed by the fact that the label is an A. So I've put the inflow amount in this first column. The first annual series was 2,000, and the second annual series was 3,000. There's only a couple of outflows, this 1,500 outflow, then a 3,500 outflow. And then the net cash flow is the difference between the two. Yeah, there's a couple of things on this drawing that don't go into the table. The first is the interest rate. I'm glad you asked about that. It's not just at year 4 that the interest rate would apply. You know, when you see diagrams like this in the future, the interest rate would be for all of the years. And that is what you would need to know in order to find P. So here we're leaving P as an unknown. You can see I've just put it as, we know it's not an inflow, it's an outflow, but I'm leaving it as a question mark because we're not going to solve for the unknown quite yet. We're going to do that in the subsequent class.
It's supposed to be the negative sign. It's like a negative question mark.
Yeah.
It's going to be negative.
It's negative, but I'm not putting the negative signs in the outflow column because I already know outflow is sort of like negative cash. Here I do because my formula is in minus out. And so then that's where the negative comes from, is because my formula for each of these is just the inflow column minus the outflow column equals NCF. In the back. Yeah. How did I know the amount was 2,000 instead of 3,000? It's just the height of the arrow, because the arrow was again the same height as the years before it. And then in year 6, 7, and 8, the arrow height is noticeably larger. Yeah. Good question. So the I, that 8.5, in the future, when we start doing like the whole problem and not just interpreting the numbers, the interest would be per year and it would apply for every year equally. For now, you don't have to worry too much about the I. You'll see it again in the future. And you also don't have to worry too much about P. You know, that's what we're going to be solving for. These sorts of problems in the future, what you'll actually be asked is, you know, for all of that amount in the future, how much is it worth today? So P equals question mark. The interpretation of this problem is, what is the value of getting 2,000 in year 1, 2,000 in year 2, and so on? You know, how much is that worth today instead of all those different amounts in the future? That's what we'll be doing eventually. Do you have other questions about translating the cash flow diagram into a cash flow table? Yes?
Now we're supposed to calculate the interest rate throughout the year?
Nope, there's no further calculations necessary. For this, it's just translating it into a table. You don't have to find the amounts. Okay, so on the back side of the paper are 1, 2, 3, 4 problems where I'd like you to now draw a cash flow diagram. And you should put the labels F, P, and A anytime you see an amount that applies. And so you can use this as an example. A means an annual series, which is where the amount is the same every year. F is when it's just a single one-time amount in the future. And then P is the amount now at year 0. Okay? Which one? In question 4, yeah, the F is up. Okay, let's make sure we're all on the same page for problem 3 and problem 4. Okay, so problem 3, we get 25,000 dirhams today, which means year 0, and we're receiving it, so it's a line up. And we put the P variable on there because it's in the present. And then in 3 years you pay 30,000. That means it's a one-time payment of 30,000. Since we're paying it, that's a line down. It's an outflow from our perspective, and that's a future amount. So F equals 30,000. And then 4 is the mirror image of that, because instead of from our perspective, problem 4 is asking, what does that look like from the bank's perspective? And so what happens with the bank is that they are paying you 25,000 at year 0, and then they receive a payment inflow to them of 30,000 in year 3. So any questions about these first two? All right. The last two are a little more tricky, so I'll give you more time to keep working on that. Okay, so in problem 5, she is spending $550,000 at year 0, and then has a revenue of every year of $85,000. How did you know that you shouldn't put $85,000 at year 0? Hey, because the machine hasn't been used yet in year 0. You're using the machine to generate revenue. So the first year, the money for working during that 1 year is inflow here at line 1. So there would be no reason for receiving revenue yet in year 0. The machine was just purchased. So it happens every year for 6 years. And so here's 1, 2, 3, 4, 5, 6. And it's an annual series of $85,000. And then there is a single payment of $50,000 that she receives for selling the used equipment as scrap. If you like, you can combine these two lines together for one single line, and then you'd put, what is it, 135,000? So you could say F equals 135,000, and that's fine. Or you can say you've got an annual series for 6 years, and then on top of the last year is a single F of 50,000. Question in the back? In the end of the 7th year, in the example here? No, it's at the 6th. It's at the 6th. Right. Other questions about this one? There's 2 ways of doing it. My way, what I'm showing here, see how this line is separate? That means that the annual series includes year 6. Or you could have one big line with F equals 135, but then that would mean the annual series stops at year 5. So those are the 2 different ways, and you'll get the same answer when eventually you do whatever calculation you need to do. Okay, here's the last one. This one's a trick question. Maybe there's no such thing as a trick question, but if there was, the trick here is that it says bank perspective at the end, you know? Okay, so you are depositing 10,000 dirhams at the end of every year for 6 years. When it says here you save the money, we're talking about a bank, so that doesn't mean like some expenses being reduced. It means saving money like you're saving it in the bank or you're depositing money in the bank. So you're depositing 10,000 dirhams every year at the end of 6 years. And then at the end of the 7th year, you withdraw the money. But the bank, what they see it is, the bank is getting money every year, and then at the end of the 7th year, the bank has to pay it out. Now, we don't know the amount yet because we don't know how much interest has accumulated during that period. And so we have an annual series of 10,000 and then a future amount that's not yet known. Are there questions from this last problem? Okay. Hold on to this paper. It'll be like a useful guide for you as you begin the problems in the homework and want to reinforce to yourself what is the standard way of representing a cash flow diagram. Yes? The solutions are only on the videos. I don't post the PDFs of the solution, so you can go to the videos for it. Just as a reminder, homework 2 is due on Tuesday at the beginning of class, so I will see you then.